Good evening, guys. I want to introduce a new project this evening. We call it the OneIOT API. It's also called Project Krikkit with an eclipse for all those fans of the Hitchhiker's Guide to the Galaxy people. Project Krikkit. So, really don't need to introduce. Sorry. Okay. Can you hear me better now? Okay. So I really don't need to introduce what IoT is to this audience, but what I really want to talk about today is how we make sense of all the data that's flowing through this new IoT sensors that and the network that's going to be producing large amounts of data, right? Typically, this is what happens. There's a huge amounts of data that's going to the IoT gateway. The gateway filters some of the information and sends it to the cloud. At the cloud, typically we're having higher order algorithms, machine learning algorithms, and other mechanisms by which we're generating knowledge, right? And we're trying to make sense of this information. But in the domain of IoT, we can't keep all of the data stored right at the cloud. So what we need to do is start getting rid of a lot of redundant data right at the edge. We want to start using that knowledge to create information right from the edge, and in the end provide a more consolidated version of the information as wisdom to the human consumer, who's the end user of all of this information. So what we'd like to talk about is more the DIKW framework, as we call it: data, information, knowledge, and wisdom. So in this particular framework, what we're missing as of today is a standard interface to all the different IoT gateways through which anybody who has a domain-specific algorithm or domain-specific operation that's going to be running in the cloud to access that information from the edge devices. And that is what Project Krikkit is all about. We are trying to define how you can define rules or the way you want to extract the information right from the edge and pass it on as input to your higher order algorithms running in the cloud. These rules can be anything ranging from thresholding of information or simple Boolean algebra on the information that's being generated by the sensors and so forth. So the problem statement is to realize the potential of IoT, we need to program policies to listen to and detect events at the edge. So we basically want to elevate the level of programming that a person who's writing domain-specific algorithms to be in the space of events rather than in the space of data, right? So we want to talk about something that's very relevant to them and not have to deal with the raw data that is coming through. Excuse me. So with the APIs, we want to create the mechanisms to acquire this information, make sense of the information, or rather do some basic processing on this information and then pass it on to the higher layers. And you can take a look at the proposal that's available at this link. So typically, this would be the architecture, right? Where a user program sends the message to the message which describes the policy or describes the interpretation of the data that they're interested in to the edge devices, and the edge devices transform the data that is coming in from the various sensor devices into the information that's information that's requested by the user. And the APIs are going to sit right there, and that is the scope of Project Krikkit as we'd like to describe it. And obviously, the two parts to the API, sorry. One is the user part, which would be consumed by the programmer or the event-specific the person who's writing the event-specific algorithms. And the other part of the API, which is basically making sense of that standard interface into something that's specific to a particular gateway router, right? Like, for example, a Cisco device could have a different interpretation of the same interface that's provided to the user as opposed to the Sierra Wireless or a Eurotech device, right? So that's the way we want to set this up. So we're able to create that generic interface to the application programmer right at the edge. So one of the examples of the way we do it right now, one of the solutions that we have is what we call data in motion, and this is the way. This is one of the mechanisms that is receiving the policies from the user and being used to convert the data from the sensors to pass it on to the users, right? The traditional mechanism of receiving data is basically you receive the data, you store it, and then you run your analytics algorithms and you process it later. But that's a long round trip and a long loop, a cycle rather. What we want to do is we want to analyze first and store later. That's our theme for what we want to put at the edge devices, right? And again, there can be a lot of different specific pieces that do pretty much the same thing. Again, by different vendors, right? So we take the data, process it first, and then if it's really necessary for us or relevant to the particular application we're talking about, then we go ahead and store it or decide what we want to do with it further. So this is the piece that will actually be the other part of the API. In the slides before, we spoke about two parts to the API. One is the part that is going to be consumed by the application programmer, and the other one that's sitting on the edge device. We call data in motion as the part that's going to be sitting on the edge device and going to be doing the analysis of the data, the basic analysis of the data before passing it on. And any person who's writing domain-specific algorithms can consume it through the OneIOT API layer. And then we have multiple third-party tools that can also do pretty much the same thing, and they will still be consumed through the OneIOT API layer. And that's the goal of the project in a sense, right? And we have Eclipse right over there. One of the real-world value propositions of this API layer is in different verticals where there are sensors that are deployed far and wide and very heterogeneous types of sensors, and the people who are actually trying to make sense of it have no idea of what the sensors are producing. So we want to have that knowledge of domain-specific knowledge go back into the edge as rules, as a way of interpreting the data and elevating all of that data into the event space in which they can start programming. So oil and gas is one very big example, and we're seeing how they can consume this API layer for their application program. Their application programmers can consume this API layer. Any questions? So this is, yes? Mm-hmm. So the reason is simplicity. The other protocol format that we did consider was CBOR, but the issue with CBOR is that think about it as if someone wanted to write the whole thing by hand, not consume the API layer that is being provided to them, and they just wanted to write the whole thing by hand, they should be able to do that also. So ease of use was the reason why we chose JSON and not any other. True, but again, you have to be progressive, right? Any other questions? All right, thank you very much.